Hello students, welcome to the topic differentiability. In my last video you learned that how to find derivative of composite functions of the type trigonometric composite, function raised to n, and root f of x type functions. I hope you understood these three types composite functions, how to write the derivative. So now in this video I am going to discuss examples on derivative of composite functions of the another type. Okay, that means you are learning one more type composite function and example on that. Okay, let me see the first type of the function. So derivative of a composite function of the type 1 upon function raised to n. Okay, and this function is composite of the function 1 upon x raised to n. Okay, standard function is 1 upon x raised to n. So that function composite this is because x is replaced by f of x here. You can see that. Now see the rule. Remember the following rule. D by dx of 1 upon function raised to n, that is f of x raised to n, is equal to, okay, before writing derivative answer, see the derivative of a standard function. D by dx of 1 upon x raised to n. 1 upon x raised to n function derivative is equal to, okay, it is like this, minus n, that means power, take negative sign, whole divided by x to the power, add 1 to this power, that is n plus 1. So like this it is answer. Okay, so what is the derivative of d by dx of 1 upon x raised to n? Minus n divided by x raised to n plus 1. Okay, now if it is composite, means if this x is replaced by any function, here also we replace by function and into d by dx of function. Okay, see here I will show you how to write. First you write numerator minus n, that is this power, minus n, function as it is, and then add 1 to the power into d by dx of f of x. So this is the way of writing a derivative if the function of this form. Okay, I hope you understood and remember this method of writing answer. Now let me take the problem. First example, if y is equal to 3x plus 2 whole raised to 5, then find dy by dx. Okay, so now this f of x is 1 upon function raised to n form. This y function is 1 upon function raised to n, where n is 5 and function is 3x plus 2. I hope you understood the given function. Okay, you know that method of writing solution. First always we take a given function y is equal to 1 upon 3x plus 2 whole raised to 5. Differentiate this with respect to x. dy by dx is equal to, okay, recall that formula. Okay, so this is the formula. I follow this formula now. Minus n means what is the n here? 5. So minus 5 divided by, and function as it is, that is 3x plus 2 as it is, you can see here, and add 1 to this power, that is 5 plus 1 becomes 6, into d by dx of function, that is bracket term, that is 3x plus 2. I hope you understood how the derivative is written. Okay, in the next step, here d by dx of function we have no 3x plus 2, that derivative answer if you write, so that become solution. So now write that derivative. So this function as it is, minus 5 divided by 3x plus 2 whole raised to 6 into, now I write the derivative of this 3x plus 2. In this 3 is a constant, x is function. Okay, what is the derivative of x? 1, therefore it becomes 3 into 1, and 2 is a constant, therefore its derivative is 0. So further, minus 5 divided by 3x plus 2 whole raised to 6 as it is, and this becomes 3 into 3. So in the next line, in the next step, just multiply these two numbers. That is the final step. Minus 15 divided by 3x plus 2 whole raised to 6. So this is derivative of the given function. So in this way, you have to follow the derivative of the function of the type 1 upon f of x raised to n. So even you can skip these two steps. Directly you can write the answer this third step. Like this, first you follow this first part, and this d by dx of f of x you find out in mind and directly write it. If it is a simple function, no, so you can think derivative of this function very easily. So 3x plus 2 linear algebraic, it is 3. So write it 3 direct answer. Okay, no problem. So let's move to second question. Similar type. If y is equal to 1 upon 3 minus 4x whole cube, then find dy by dx. So given that 1 upon y is equal to 1 upon 3 minus 4x whole cube. See here in the bracket, that is this f of x may be linear, quadratic, cubic, polynomial, whatever f of x, the rule is same. And whatever this power, fraction, even, odd, whatever, so method of writing derivative is same. Y is equal to 1 upon function raised to n. We follow that only. Okay, minus n here 3. So n is 3 means minus 3 divided by function as it is, add 1 to this, that is 3 plus 1 4 into d by dx of function you take 3 minus 4x. Okay, next dy by dx is equal to, so first term as it is into d by dx of 3 minus 4x. Okay, now here 3 first we have, therefore its derivative is 0, minus as it is 4 into x derivative is 1, therefore 4 into 1. So this become minus 3 divided by 3 minus 4x raised to 4 as it is, and this is minus 4. And this minus 4 into minus 3 become 12. So that is the final answer. That is 12 divided by 3 minus 4x whole raised to 4. So this is derivative of the given function. So this is a very simple rule, and this rule is same as differentiating trigonometric composite. First we find the derivative of main function, then composite variable. No, in the same way this is also. First we follow here main function derivative, that is 1 upon x raised to n. We follow that n into function raised to n plus 1. Then we differentiate composite variable. Okay, so the same rule is only following. So next see another example, but it is not algebraic, now it is trigonometric. Sine raised to 4 x variable, then find dy by dx. Y is equal to 1 upon sine raised to 4x, sine raised to 4 into x variable. Differentiate this with respect to s. So you know already the rule. So this is a 1 upon function raised to n form. 4 is the n, therefore minus 4 divided by 1, if you add it become 5. So d by dx of sin x. So you know the derivative of sin x, it is cos x. So rewriting this, we get minus 4 cos x divided by sin raised to 5 x variable. So this is derivative of the given function. I hope you are getting, students, how to write derivative for this type of example. Next example, if y is equal to 1 divided by sin x minus cos x whole raised to 5, then find dy by dx. This also same type example. If first you write given function y is equal to 1 upon sin x minus cos x raised to 5, then write differentiate with respect to x. Left side dy by dx is equal to, okay, now this is the formula, and here function is sin x minus cos x. So I follow this formula now. N is 5, therefore numerator is minus 5 divided by sin x minus cos x raised to 6 into d by dx of function. So in the next step, if you write the derivative of the sin x minus cos x, that completes the derivative of the given function. So first function as it is into, okay, next derivative of sin x is cos x and minus cos x derivative is minus sin x. Further, minus 5 divided by sin x minus cos x raised to 6 into, so multiplying this negative, you will get cos x plus sin x, and rewriting the function, it becomes minus 5 into cos x plus sin x whole divided by sin x minus cos x whole raised to 6. So this is the derivative of the given function. I hope you're getting a method of writing derivative of the function of the type 1 upon function raised to n. Next, students, I am going to discuss derivative of composite of three functions. So far I discussed composite of two functions, that is f of g. The given y function or given function is of the type f of g. Now three type. See, when we have f of g, first we differentiated f function and then g function we differentiated into composite variable. In the same way, here three times you have to do it. F function first, g function first, then h function derivative, like this: df upon dg, dg divided by dh, and dh divided by dx. Three times composite. So how many times, how many functions composite? No, that much you have to differentiate. That is called as a chain rule, chain system. Okay, now I take the problem and I discuss the derivative. If y is equal to sine of cos 2x, then find dy by dx. Okay, see here, dear students, here in this function you can see that we have three functions. One is sine function, one is sine function entire, and in that variable is now cos 2x function. Okay, that means cos 2x is become g function, sine of g. Okay, now this g is not a standard. This is again composite, cos of 2x. That means this 2x is now I take it as a h, cos of h. That is g of h. So this is f, this is g, and this is h. So one by one function you differentiate. That is the derivative of the y function. Okay, I will show you how to write. If y, first you write given function. Okay, so first here main function is first main function in this three. Sine is the main. Okay, you know how to write the derivative for sine composite. Sine when you have, then function is written as cos of composite. So this is the composite variable, no, cos 2x. This is variable, so that we have to keep as it is. First you write sine derivative cos 2x as it is. See here, into d by dx of cos 2x. Okay, I hope you understood. First we write main function derivative, then composite variable. So in the next line, you have to write the derivative of this cos 2x. No, in previous case what happened in previous examples, this part we got standard function, therefore we written directly derivative answer. Now here again you see the function, it is not a standard, it is a cos of 2x, means it is a composite. So again here you have to follow the composite rule. Okay, so again you have to identify it is which type of composite function. Again it is a trigonometric. Cos, first we have cos, that is trigonometric. So what is the derivative of cos? Minus sine composite variable 2x as it is, okay, into d by dx of this composite variable, that is 2x. So this is part wise. This function is written derivative of sine first function, and this derivative is second function derivative. Next here I am writing third term, cos of cos 2x as it is minus sine 2x as it is into d by dx of 2x means it is 2 into 1. So rewriting this function minus 2 cos 2x into sin 2x. So this is the derivative of the given function. One by one you have to differentiate. First I differentiated sine, then d by dx of cos 2x. Next line cos 2x, again composite rule, cos function derivative and 2x derivative. Okay, now I return solution stepwise. You have to follow directly. Okay, this line you can write directly. See here I will show you, I will say you. First you write sine derivative, that is cos, keep this variable as it is, into next this variable derivative you have to follow, that is cos derivative minus sine 2x, and what is the 2x derivative? 2. You write it directly 2. One by one function derivative you write it, that become a solution. I hope you got it. So next one more example, then you will definitely will understand how to write a composite derivative for the composite of three functions. Okay, now if y is equal to sine of cos of x square, then find dy by dx. So this is now composite of three functions. Y is equal to sine of cos of x square. Y is equal to sine of cos of x square. So first write dy by dx, left side is equal to, you know, the derivative for sine. Okay, it is given by cos and composite variable as it is. See, composite variable cos of x square as it is into d by dx of, now composite variable is cos of x square as it is. Okay, dy by dx is equal to cos of cos x square as it is into, now cos x square derivative minus a sine x square into d by dx of x square. Okay, so in next line just write derivative of x square, it become 2x. Okay, so rewriting this function, it become minus 2x cos of cos x square into sine of x square. So here also you can write the solution directly, one by one function derivative writing. See here, first I write sine function derivative, it is cos of cos x square. Then next is this function derivative minus sine x square. Okay, it is composite. Now this variable we keep as it is. Next this variable derivative 2x. Once again I repeat, first this answer is derivative of sine, that is cos of cos x square. This is this function derivative minus sine, this is as it is. Next this function derivative. Okay, so this is the way of writing derivative for composite function of three composite functions. Okay, now take another example. Y is equal to secant of tan root x. So this is NCERT textbook example. Even previous example also NCERT textbook example. You have to give more importance to NCERT examples in examinations. In examination you will get maximum the NCERT textbook examples. Given y is equal to secant tan of root x, differentiate dy by dx is equal to, first we have to write secant derivative. So this is the secant derivative. Secant, how it is, right side, secant into tan, it is product of two function. Okay, so first write a second function derivative, that is secant. Now I keep this composite variable as it is, this is as it is, into tan, again variable as it is. So this product now derivative of secant into, now you take derivative of this composite variable, that is d by dx of tan root x. Okay, so first two terms as it is, dy by dx is equal to secant tan root x, tan of tan root x into, now derivative of tan root x. So first here this is also composite. First you write derivative for tan, that is secant square root x into d by dx of root x, that is derivative. Okay, in the next step, first two terms as it is, secant tan root x into tan root x, and secant square root x as it is into, now I write derivative of root x. The derivative of root x is 1 upon 2 root x. So this is the solution. So this answer also we follow the same way, one by one function, right? Derivative writing. See here, secant first. Secant is product of these two, and this variable as it is, tan root x, tan root x. Next, tan root x derivative is tan, derivative is secant square, root x as it is. Next, root x derivative is 1 by 2 root x. 1 by 1 function derivative it is. Go for next problem. If y is equal to 2 root cot x square, then find dy by dx. So this is also textbook problem. If y is equal to 2 into root of x square. See here, we have three functions. One is root function, root of f of x. Okay, that is composite. After that, whatever f of x is there, it is also composite. It is not cot x, it is cot x square. So here, this is f, this is g, and this is h. F, g, h. I hope you understood this three types. Now, see the solution. First, you write given y function, y is equal to 2 into root x cot x square, and then dy by dx. Okay, recall that root f of x derivative. So root of any function, if I have how it is written, 1 by 2 same function into d by dx of inside a root what is their function, that function derivative. Okay, I follow the same. First, I keep this constant as it is. This is constant multiplied to the function now, keep as it is, into, now I write the derivative for this 1 upon 2 given function, that is root cot x square, into what is the inside function, cot x square, that is derivative. Okay, so this whatever is written, it is the derivative for root, this part. Okay, next what we are writing, derivative for inside function. Okay, here in this 2 and 2 get cancelled. So next is 1 upon root cot x square. Now I am writing derivative for cot x square. Okay, it is a composite. Now I give you cot function, main function derivative, that is cot x. Here see variable x I took. Cot x variable or cot x function derivative is minus cosec square of x. Now instead of x, x square is there, you just take x square and into d by dx of x square. Okay, so first you write for cot, that is minus cosec square, keep this variable as it is, into d by dx of x square. So next here, the first whatever I written, it is a derivative for only cot. After that, derivative for x square variable. So rewriting this become 1 upon cot x square, this function as it is, and then derivative of x square is 2x. So rewriting this function, it become minus 2x cosec square x square divided by root of cot x square. I hope you understood how to write the derivative for composite function of three types, three functions. And dear students, note down 15 examples and trying to write the derivative for these 15 problems. Thank you all.